So, when we name organic molecules, the core of what we think about is just how many carbons form the chain or form the ring that we're looking at. So, let's say I have something like this, and hopefully you're reasonably familiar with what this represents. So, let's say I have something like this. Let's say that that is the molecular structure right there. And so, the first question you should be asking is, how many carbons are there? And you might say, how is that even a molecule? And as a review, endpoint of every line represents a carbon. So that's a carbon, 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 that's a carbon. And we have 1, 2, 3, 4, 5, 6 carbons. And we have no double bonds. So if you have all of that information, you are ready to name this molecule. And before I actually name it, let me just kind of give you all of the different prefixes. So if you have one carbon, the prefix is going to be meth, M-E-T-H. Now let's say you have two carbons, the prefix is eth, E-T-H. It's good to memorize at least up to 10, and it kind of repeats after that. If you have three carbons, the prefix is prop, P-R-O-P, prop, like propane, and you've heard of ethane and methane. So you'll see all of that soon. 4, you're talking about bute, B-U-T-E. And after 5, it becomes the traditional prefixes we associate with a lot of these numbers. So at 5, it's pent, like pentagon. 6, it's hex, like hexagon. Next is our 7, like hept. 8 is an oct, like octagon. And the next 9 is a non, and 10 is dec. And then after that, it kind of starts to have a pattern here. You might not deal with these things beyond your teens, but I'll just write them down here. So the next is 11, and it is undec. And for those of you who know French, I am not one of them, but I know that one in French is un, or in Spanish, uno. So it's kind of 1 and 10, 11. Now, number 12 is do dec, or dos if you're speaking Spanish. So for 2, it is do, and for 10, it is dec. That's 12. 13, you could imagine what it's going to be. It is tridec. And the next is 14, and it is going to be tetradec. Like a tetrapod, it is something with 4 legs. And then after that, it becomes very systematic. At 15, it is pentadec. Do you notice pent? Pent is 5, and dec is 10. Then the number 16 is hexadec, and then number 17 is heptadec. So it just goes on like hexadec, heptadec, octadec is 18, and then 19 is nonadec. And then 20 is actually ESO, but we won't even go into that. I mean, at last, that would be useful for us now. I could do up to 16, which is hexadec. So this is just how many carbons are in our longest chain. What I drew here is just one chain. Let's try to name it. Well, how many carbons do we have here? We have 1, 2, 3, 4, 5, and 6 carbons. So we'll be dealing with hex as a prefix. And then to get a postfix on this, you look to see if there are any double bonds here, and there are no double bonds here. And if we have no double bonds in this carbon chain, we're dealing with an alkane. This is called an alkane, which is a general term for all of the chains of carbons that have no double bonds on them or no triple bonds, all single bonds. So in this situation, you take hex for 6. So this is hex. And then, because it's an alkane, it gets the ane from alkane. And so, then this is hexane. Now it is time to try and do another one. Let's say that I have this thing right over here. I will draw it, and let's make it even longer. So now here, as you can see, how many carbons do we have? We have 1, 2, 3, 4, 5, 6, 7 carbons. And they are all single bonds. So it's an alkane. So this will be 7 carbons. It is going to be heptane, because right over here, as we saw, we have all single bonds. Now, if these things form a chain, or if this forms a ring, I should say we put the prefix cyclo in front of it. Did you not get it? Let me show you what I'm actually and exactly talking about. So if I just have 5 carbons, 1, 2, 3, 4, and 5, so that is number 5. The bonds are 1, 2, 3, 4, 5, These are the carbons in a chain. If I just have 5 carbons in a chain like this would be pentane. Let me write it over here. Pentane. But if I have 5 carbons, then they form a ring. Let me just draw it for you. So it's 1, 2, 3, 4, 5 carbons, and it forms a circular like ring. That's bad. Let me make the drawing a little bit better. So actually, I'm just drawing a pentagon, but notice this has 5 carbons on it. I could draw the carbons here, and these are all the carbons. What you don't see is the hydrogens they're bonded to. Each have 2 bonds with hydrogens. And I will draw it here just as a bit of a review, but you notice very quickly the drawing gets extremely messy when you draw the 2 hydrogens on each of these carbons. So it's a little bit over. Maybe I shouldn't be doing that. So it becomes very messy when you draw the hydrogens, so it's better to just assume that they're there. If we don't draw all 4 bonds, the other 2 bonds are going to be with hydrogen. So here, this is an alkane because I don't have any double bonds here. All are single bonds with the carbon. There are 5 carbons, so you might think it is pentane. It's in a ring, so we add the prefix cyclo to it. So this is, because it's a ring, we write cyclopentane. I will just break this apart for you once. This cyclo right here tells us that we are dealing with a ring, and you will see that this is a ring right there. This particular piece of information clearly indicates that we are dealing with a total of 5 carbon atoms. And then this specific part right here, namely the ane portion, explicitly signifies that every single bond present between the carbon atoms is a single bond, without any presence of double or triple bonds, no double or triple bonds, just all single bonds. Let's start with the word, and let's see if we can figure out what the actual structure would look like. So let's say I have cyclononane. Let me just clear this space for us to write more here. And here we can start to understand this in a better way. So what is this telling me? This tells me I'm dealing with a ring, and that their cyclo, that is a ring. It's going to have a ring structure. It is going to have a total of 9 carbon atoms, which means 9 Cs in total. And since it is classified as an alkane, that means all of the bonds between these carbon atoms are going to be single bonds. So if I want to draw it, I want to draw 9 carbons in a ring. It's not really a very trivial thing to draw. Let me try my best. Let's see. That's 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. That's about it. Now let's see. Let me draw it. Let me try a better shot at it. Let's see. I have 1, 2, 3, 4, 5, 6, 7, 8, and then 9, and then you can connect the last 2. So let me make sure that you can see all the edges right here in my beautiful drawing. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So it's in a cycle, it's in a ring. I have 9 carbons, they're all single bonded. So this is cyclononane, although there's probably better ways to draw that ring right there. So if someone were to tell you octane, and that word might feel familiar to you from the gas station, and they are literally talking about the molecule octane, and now you know, or at least you have a sense of what they're talking about. The OCT tells you that you have 8 carbons. There is no cyclo in front of it. So it's not a cycle, it's just going to be a chain. And then the ane part tells you that they're all single bonds. So it's just going to be 8 carbons in a chain. And if we take a moment to count them here, let's see starting from the first one. 1, 2, 3, 4, 5, 6, 7, and 8. That makes a total of 8. In the next few videos, we will add more to these molecules and make the names even more complex.